Hello everyone, so for today's video I'm going to be disassembling the range extender generator inverter unit from the BMW i3. So this one I managed to get off eBay for £56, which is an absolute steal because normally these are selling for about £200 to £400. So I just had to take advantage. So this is the one I bought off eBay. I reckon the one in my car is faulty because I was reading somewhere that the high voltage insulation error comes from the module itself being faulty rather than the cabling, although that's not always the case. So I've got a couple of theories about this thing. This is basically just an electric vehicle motor inverter, which in the case of the BMW i3 is just operating in regenerative mode nearly all the time. So the only time it acts as a motor is when it's supplying power, three-phase power out of here to the range extender generator to use it as a motor to start the engine. And the rest of the time it just runs in regenerative braking mode, and the power flows back out here towards the charge controller unit for the battery. So I've got another theory as well, and this is that I think this inverter is actually used on the BMW C Evolution electric scooter as well. Although I'm not totally sure on that one. So I reckon actually it would be possible to take the you probably could actually take the main control circuit board out of this if you don't have the skills to actually understand how it works, and then put your own one in and just basically turn this into a controller for a small electric car or motorcycle, or rather powerful motorcycle. Because this is the output, you could in theory just drill a hole in each tab and then just bolt on some sort of lug terminal with your cables attached. This connector might be trickier. You'd either have to get a high voltage cable off eBay, and then just cut it and then attach it to whatever you want. And you could probably get the power into it that way. So this thing does run on, it does have about a maximum of about 390 volts running through it, so it's maybe quite impractical to use for most projects, although if you were to use your own circuit board in it, you could probably run it at lower voltages. So that's just an idea. So I'll get on with removing the top cover and we'll see what's inside. The screws actually seem to come out pretty easily on this. Another thing I forgot to mention is the size of the unit. It's fairly large. Weight wise, it's not actually all that heavy. 4 kilograms maybe. It's not a heavy thing at all. So the only thing is, I have to take this cover off. I might have to put Hylomar blue gasket sealer around it, just to seal it back up again, because we don't want moisture getting into these. That plug there is probably where all the CAN bus and control signals go in. So it's beyond my capabilities just now to be able to actually understand how all that works. Okay, so let's see if the lid will come off. It's probably not going to come off without a fight because this has been sealed shut for quite a long time. Just got to be really gentle. There we go. Okay. I think it's just the seal around this connection that's stopping the lid from coming off. There we go. Okay, so what I'll have, this main control circuit board here. Underneath it, we will have the main power electronics, such as the IGBT units. Those are like the enormous transistors which switch the three-phase power to the motor. So yeah, we won't need Hylamar blue, that's just a rubber seal, so that should be okay. So what I'll do is I'll just give you a close-up view of all the chips, so you can maybe take down their numbers for your own investigation if you want to try this. So there we go. Don't you know what that says? Ultra or something. What else do we have? This one here. Of course, I've no idea what these even do. That's all the chips on that side. Right. Next, I'll try taking out, well, maybe these screws here. If I take these out, that should be okay. I'm gonna have to take that one out as well. Why they made it a different size, I don't know. Did they make it a different size? No, it's not. So we'll take those out. Okay, so that's looking to me like it's going to want to come out now, so you'll need to unplug these little connections here. Seems like this one's not really wanting to come out without a fight. So you just got to be very careful with them. It just pulls out. Same with this one over here. It's blocked by this capacitor, so got to be careful. That one just lifts out quite easily. Another thing to note is I think that's the transformer, the high frequency transformer for the switch mode power supply inside this thing, which would create the lower voltages, like say 12 volts or 5 volts or whatever, to run all the control electronics in here. There's probably a lot more underneath this, but it's glued on. I'm not wanting to damage this too much because I'm actually going to be putting this in my car at some point if the one I've got just now packs in completely. So I reckon in regards to the IGBT modules, that's most likely to be them there. I think the whole H bridge, the three-phase H bridge, is just in one big unit, and that could be it there. Although alternatively, no, that's incorrect actually. If I have a look here, these are the IGBT units. That's in there. So this might actually be a big capacitor. That's what I'm thinking. This is possibly a capacitor. Yeah, because yeah, there we go. 420 microfarads, 450 volt DC. So this is just a huge capacitor that's encased in aluminium for some reason. And it's obviously going to be a very, very high quality capacitor. It's not going to be an aluminium electrolytic capacitor, because those eventually dry out. For automotive applications like this, you need stuff which is going to last many, many years. So that's probably, I don't know, it'll be some sort of dry type capacitor. So yeah, it's looking to me like the IGBT units, switching units, are this part here. That's a whole H bridge right there. So, and that's going out to this connector on here, which would go to the generator unit. So we'll try and get more screws out and see if we can look into this a bit deeper. Right, so I've taken out every single screw that I can, and I just had to sort of lever this whole assembly gently, so it's like it's maybe all going to lift out, so I can actually show you more of what parts are in here. I was actually about to stop this disassembly at this point because I thought I was maybe going to damage something, so should just be able to lift out capacitor and H-bridge assembly. So here we go. Let's try and get this last screw here. There we go. Right. Thermal compound, yuck. Okay. I'm going to have to try and replace that maybe. It shouldn't be too much of a problem because I've got thermal compound anyway. So let's have a little look here. We have Infineon chips. These are probably IGBT gate drivers. These Infineon units here, as well as lots of other stuff, probably for sensing current. So you have a huge IGBT units on the bottom, 3 of them. So that's going to form an H-bridge. I was actually wondering where the power is actually getting into them about, and it just seems to be on the output side of this big capacitor here. So the power is getting into them through there, and it's obviously coming out through the bottom. I wish I actually knew what IGBTs they were, but I'm not prepared to take this thing apart any further because I'll probably end up destroying it completely, so I don't want to do that. I know it only costs £56, but which is quite cheap for one of these. And we've got more of the same Infineon stuff up here. So this side must be the upper, well, one half of the H-bridge. Say for instance the top 3 transistors you'd find in an H-bridge, and the other circuit board must be doing the bottom 3, so each IGBT must be like, say for instance that's the top and bottom half of that, which does like phase 3 and phase 2 and phase 1, so they're probably half bridge IGBT modules. So what I'm going to have to do is clean all this thermal compound off and then replace it. So I've got stuff which is normally used for CPU coolers, and that should hopefully do it. So yeah, that's pretty much it. That's all there is to it. I reckon with enough reverse engineering of just this module here, you'd actually be able to make a functioning electric vehicle inverter out of this, no problem. I can't do it just now because I just simply do not have the know-how to do that. It's a bit beyond me at the moment, sadly, but I certainly believe it's possible. Or in fact, you could even take this whole unit itself and just mount it in something even more compact, so you could have actually a very light and compact electric vehicle inverter for, say, a high performance motorbike. Although probably a 40 horsepower motorbike, but even so, that's quite a bit. So yeah, there we have it.